Okay, in this video, we're going to talk about search. So let's first think about this data file, numbers.txt. So the numbers.txt will contain all the doubles. The first line is basically how many doubles there are. So there's 5 doubles, and you will see 5 doubles after that. And this search program is first taking the file name. So I'll just give numbers.txt. And then it allows the user to put some query. So for example, if I put 100.12 and it says it has 100.12, or if you have 30 numbers.txt and then query give, if you give 30 as a query, then it says no. Okay, it's a simple program. So let's write some program. Okay, so we're gonna systemize the search idea. So what do I mean by that? We're gonna have search function. Okay, so it'll be taking an array of doubles. Okay, so A is the pointer to array, and N is the number of elements in the array. And then you will be given query. Okay, okay, input is what? A and N. This is array. And Q is what? Query. Okay. And then what? Output is as before in sorting, especially for the find first function, we're gonna output the index. Okay, if there's a match with the query, you actually output the index of the matched element. This is, of course, if it is success. If it's fail, usually the convention is output n, which is what? The index of the what is it? Last element plus 1, right? So index of the last element is n minus 1, okay? And then you just add 1. So I just scan through it, and now the index is basically past the last element. Okay, that means it's supposed failure. Okay, so that's the convention. We're gonna think about that. Okay. So how do you define this function? Okay, so in here, there should be main function. We're gonna talk about main function later. That's not the focus today. Okay. Let's first define this function. How do you define? Well, it's a simple idea, right? You scan the array, and if, okay, how do you scan the array? This is the way to scan the array. And then what? If ith element is the same as the query, what do you have to do? Well, you have to return the index of the match, which is the I. Otherwise, you output the index of the last element plus 1. So that search function is simple function. Okay, now what? So in the main function, you printf what? Enter file name. What was it, file name? Let's just do file name to make things easier for us. And then you have to read file name. So that means you should have string to store the file name from the terminal. So you read the string from the terminal into this file name, f names, string variable. You're done. And then what? Now what? You have to open the file given the file name. So f open, and then give file name, and then you're reading it, reading the file. So it's a read mode. Okay, remember the numbers.txt file looks like this. So that means what? You should have n, and then you gotta read the first 5, number 5 into n. So fscanf should be the function because you're reading from a file. And the first argument is like the file pointer. And then formatting is %d because you're reading an integer into a variable n. Now what? You know how many numbers. So I'm going to create a stack-based array of size n, a double type, and then I'm going to read the double. So again, you have to use scanf function, given f. These are doubles, so that means LG should be the thing you're reading into a sub I. Okay. Now what? So you give the file name, you read all the file data, and then what? You have to read the query data from the terminal, right? So that's from the terminal. So that means what? You should get this query value from the terminal. So that's scanf, not the fscanf. So be sure not to be confused whether when you use fscanf and when you use scanf. When you read from file, use fscanf. When you read from terminal, scanf. Okay, so you read into the terminal input into double Q. So now what? So you call search function because now you got the file data and you got the query. So it's time to call search. Okay, search A and Q. And what? If I is less than n, that's success, right? So that means what? You have to print out. Yes, it has that one. How do you pull out that one? Well, if you have index, you can access the element using that index by just pulling out the array. Otherwise, no. Okay, so simple. Before returning, it's good practice to close what you opened. Okay, so let's try to compile that. Okay, so this one, file name, numbers.txt, query one. Oh, yeah, no. What do we have? Numbers.text, query 12.8. Yes, it has 12.8. Okay, that's good. And as with the sorting, let's generalize this a little bit in terms of the comparison. And if you manipulate the comparison on point, you can actually more generalized way of comparison. Okay, what is that? What do I mean by that? Okay, let's go back this code. The comparison part is in here, right? So basically, you compare A and A sub I and Q. If they're match, well, you return I. So I'm going to take this. I'm going to generalize with match function. If AI is matching with Q, you do that. Of course, match function will be, in this case, Boolean, right? Then there are two double numbers. Well, match is what? This. Make sense? Okay, so then let's recompile this one. Bool is not included, so let's just include standard bool. Of course, let's just include standard library. For no reason, that will be apparent soon. Anyway, okay. Okay, so file name, numbers, txt, one, not good. Numbers, what do we have? Numbers.txt. Let's do this. Okay, it works. So it works as before because we did nothing but extending this idea of matching. What's interesting is if A minus B is small enough, okay, not exactly match, if it is like what? The absolute value of the difference is less than 0.5, you still count that as a match. Okay, it's a little bit different, but it's generalized approximate match. So what's interesting is what? Now you take out the match function as a separate one, and then you can manipulate this matching part quite flexibly as we did in the sort. Okay, so now, okay, then what? If you put just one, it'll find 1.1 because that's approximate match. And also, if you put 100, you can find this one. But if you put, let's say, what, 9, you cannot find it. That's pretty interesting, right?